Okay, so welcome to the AI Agent Montreal meetup.
My pleasure.
Yeah, today we have the amazing opportunity to have you, Alex, for the talk Approximation Before Precision. Little reminder about the meetup. It's a meetup for people curious about AI. We want to demystify and share and spread the best practices around it. So we can't wait to see your talk, Alex. Little reminder for the organization. The talk is recorded and I will share it on our YouTube channel. Feel free to ask any question and we will try to answer it along the presentation or at the end, depending on you, Alex. And we will share all links at the end in the comments of the YouTube channel also. So thanks to be with us, Alex, and the place is yours.
Thank you very much, Nicholas, and thank you also for inviting me. This is an exciting time in our
Yeah,
profession. Things are moving really fast. I'm going to attempt to maybe slow down a bit today,
yeah,
but please feel free to interrupt me. There's lots to talk about, and I may not be able to reach the end of the presentation depending on the time. It's a loaded subject. What I'm going to do today is I'm going to attempt to review how we work uh, as as we are engineering or developing a software
yeah,
system. The emphasis will be a little bit on the system and how I grew into, because I have decades of experience, how I grew into adopting or embracing AI to help me in my practice. So this is going to be from a personal perspective. It is something that, as they say, your mileage may vary. It may not work for other people. I'm just going to explain where I'm at. Currently, it's going to be a very simplified approach because to really show what I'm doing, it would require a workshop, like half a day or full
oh,
day workshop.
okay, yeah,
Okay. So basically, the very topic here, I think, is illustrated on the first slide, where if you look at the down at the kind of a depiction of a bridge, and this is allegedly an image before AI. So it's not something that was AI generated. Don't know if it's true or not, but allegedly you have a crew working on building a bridge. One crew started from one bank of the river, another crew started from another bank. Both crews did a stellar job. Everything is perfectly done, but the bridge is not functional because they did not meet. And so
yeah,
the precision work was stellar. The approximation or the fitting did not happen in time. And so now, you're faced with a situation where, okay, wasted so much time and basically for nothing. Why I'm saying this is I see this symptom in many, many projects that I've been part of. And has also been documented in various studies and books that a lot of when we start a project and the separation of concerns, the workload gets divvied up among different teams and different departments, and they all start working in all earnestness, and everybody's a great professional, great expert, but they fail to check for the approximation to see if the parts will fit. And so I've witnessed a number of projects where at the end of the project, like, yeah, we're all done, and then we try and put it together and somehow wouldn't fit. And then the reputation suffers, the project runs over budget and time, and there's all these like frustrations. So I think it's important for us to recognize that this is an anti-pattern or a symptom that keeps
yes.
occurring a
We need
lot.
the interaction between all teams, yeah,
Yes,
involved.
correct. And because everybody's so busy and it's kind of nose to the grindstone, and you're deep in the weeds, nobody's raising their head up and say, "Hey guys, let's check, have a little
We
bit of
need
a."
to avoid the tunnel effect, yeah.
Exactly, exactly. And another here illustration is IKEA furniture. It just so happened that 2 days ago I received a big kitchen table and I had to assemble it. And again, if I started immediately tightening the screws, the legs would be all crooked and all that. So you have to first see lay all the parts on the floor and approximately, okay, this is how it's going to look, and then little by little adding some pieces, loosely tighten so that they can later readjust until such time where it's all kind of ready, and then we really tighten the screws, and now you have a sturdy table. It's not wobbly, and my wife is happy.
And
So,
just for the AI issue, for you, it's even more important than before to have this kind of synchronization between teams. Yeah.
oh, absolutely,
Yeah.
because as you know, artificial intelligence is trained on finished products.
Yeah.
It hasn't been trained on the process that gets you to the finished product. And so when you mention anything to AI, it immediately can detect a pattern or generate a pattern and immediately shoot straight for the finished product.
Yeah.
And then it may add a lot of content and things that you absolutely don't need. And it just creates bloat. And now you have a big problem because now you have a complex system that you can't even understand. So it's very important when working with AI to keep it, what they say, on a short leash.
Yeah.
If we give it free reign, like just go and build something, yeah, okay, vibe coding, some people can, but in the long term, that system is very messy, I would say, and difficult
Okay.
to reason about, difficult to maintain. Because at the end of the day, the name of the game is called maintenance.
Yeah.
Um, software is not like software products are not like physical products like a chair or a wristwatch, where it's when it's done, it's done. You ask me to build your chair, I build your chair, you buy it, you bring it home, it's done. There's no one need to work on it. Software is not like that. So software needs to be maintained constantly. Digital rot never sleeps. Even if we don't want to add any more features, guess what? Some APIs change. There's a security loopholes. You constantly need to keep touching that product. And if the product is not maintainable, now you are in trouble because now you maybe find a bug, you fix it, but you introduce five new bugs, and we all know that from our practice. So let
And
me,
it's very important because now with the AI wave, we see only the first part, just one generation, one shot,
yeah,
and
yeah,
we don't speak about the maintenance part.
exactly. And they call it zero shot prompting. So you're zero shot, bam, you're done, you're happy, you are rich.
Yeah,
And that's
and regenerate if you're not happy.
yeah. So that's a fairy tale. Anyway, you and I, we have a lot of experience in this profession. This is not our first rodeo. We've been around the block a few times. I have some battle scars to show, and so I'm bringing to the table decades of experience. Is it okay if I proceed to the next slide?
Yeah,
Okay, thank you. So I just want to quickly mention, why is it not advancing? Let's see.
it's through. Yeah, we see
Okay. Okay, so
the book.
with regards to the AI, I have I'm a scientist by education, by training, and when I joined the university, entered the university, that was 41 years ago. Um, I got really uh, mesmerized by this book. I think I read it in 1985, and this was my first kind of very serious introduction into artificial intelligence and all these concepts.
Okay,
And so it's been on and off. As we remember back then, artificial intelligence initiative hit so-called ice age. The funding was frozen. It didn't seem to be going anywhere until, I mean, today we're witnessing the new wave, which Grady Booch calls the third golden age of software. And he has a really interesting take on that. By the way, you're in the round table, so maybe you've attended
yeah,
Grady's. Yeah, okay, fine.
tomorrow.
Yeah. And another thing that I was kind of, when I was doing my scientific study, is this book, Steps to an Ecology of Mind by Gregory Bateson. So that book introduced me to a very important, I think, aspect of software development, which is systems thinking. Because,
Okay,
we see a lot of things today where people specialize. You're a front-end developer, you're back-end, you are maybe full stack, but nobody, there's no job description for a systems specialists that know how to actually design and maintain a system, because we don't seem to have a programming language for the system. We have languages for building various components, JavaScript, C, this and that. But when it comes to the system, we are still kind of struggling. How do we keep that in mind, the entire system holistically, and how do we understand the system? Because it's not physical. It's not something you can walk around and touch and push. So conceptually, it's very hard to keep it in your mind. So anyway, I mentioned these two things so that you understand sometimes where I'm coming from. It's a bit of a scientific background.
And now we need to move. I done a talk last week about we need to move from full stack engineer to product full stack engineer now.
Yeah,
Yeah.
yeah, plus that, plus that. So even if before it was assumed that they product people know exactly what they want, we just get the blueprint and now we're building a system. But now we have to also open up. Is it something that is needed in our world? And if it's needed, how it's going to work and how it's going to affect people, and is it going to make people miserable or happy, or all these. We can talk forever about these concerns. So one thing we all know is that premature optimization is the root of all evil. Now, when I talk about these things sometimes to organizations and teams, everybody for some reason seems to assume I'm talking about performance. Like
Yeah.
it's sluggish and we have to speed it up. No, I mean, yes, performance is also part of optimization, but premature optimization is also optimization of the structure, of the design, of, as they say, over engineering would be premature optimization. Even if performance is stellar, no problem. People want to optimize on other things, over modularize, introduce microservices when there's no need for microservices, add Kubernetes where there's no need for Kubernetes. So it's all premature, right? And so that's one thing also that I think AI suffers from. Serious illness that I see is it really is calibrated towards premature optimization. It just goes and if you let it, it will load all kinds of patterns, all kinds of things into your project. And now you're like, do I really need this? Why do I have so much bloat when I want to keep things simple?
Is it about also a new feature? My point is, if the AI suggests you some feature around the business needs, uh, is it concerned about also about premature optimization with AI? Or
Yeah, both. I mean, Yagni, you aren't going to need it.
yeah,
It's the extreme programming principle that says, yeah, you are working on something, and you say, oh, I have an idea. Maybe we had this bells and whistles over there, because I'm under the hood anyway, and I think we will need it later. And Yagni says, no, you aren't going to need it.
yeah.
So don't even bother. That's one aspect of premature optimization. Another aspect is not adding new features, but just saying, okay, I'm going to extremely modularize this. I'm going to add pub sub queues. And do you really need that kind of complexity at this point? If it's simply a simple lookup, why do you need pub sub queues and all these like beefy infrastructure? That will also be premature optimization because you've seen somewhere, you watched the video where people are adding a complex infrastructure and I mean, to be honest with you, I worked on many projects where my user population is like 5 people. There's a department inside your corporation that only five people will ever be using this application. They're in the credit department, and you know exactly they'll be using from 9 to 5 p.m. No weekends.
Yeah.
Why do I need to build a beefy as if I'm going to have millions of users, right? That's premature.
Yeah.
And we know, I mean, if it ever happens that this thing explodes, then yes. But that's the question of is it maintainable? Now the question is, when I build something, and if I suspect it may grow, I better make it. For now, I keep it simple, but I make it maintainable. And so, like I say, you need to understand your product. You need to understand your domain. You need to understand your user population. You need to understand the usage patterns, how often it's going to be used, how many concurrent users, and all that. Because don't go overboard if you know that this thing is going to be used once a week, maybe one or two people. Why, you don't need to complicate things.
But translate to the AI because we delegate to the AI. Should we add more constraints? You know?
Yeah,
Yeah.
exactly. Constraints are very important, and in my view, in my world, it's extremely important. So I'm going to quickly just mention Donald Knuth. A long time ago, he said, "Real problem is that programmers have spent far too much time worrying about efficiency in the wrong places
Yeah.
and at the wrong times. Premature optimization is the root of all evil, or at least most of it in programming." So it's valid today more than ever.
It's sometimes some developer speak about pragmatism. You know, need to be pragmatic and
Yeah,
make a simple decision, like Kiss, Yanni, like you said, and
yeah,
those
yeah,
principles.
yeah. Keep it simple,
Yeah.
stupid. Um, but there's also a pragmatism is a double-edged sword because you may end up with a system that was built with duct tape and it's not maintainable.
Yeah.
So there's a middle ground. There's like gold plating and everything has to be super duper science fiction. Over here, duct tape and some piece of string, and that's extreme pragmatism. And in the middle would be maybe a practical mindset. Let's be practical. What are we building and what is it for, and what is the projected growth? Things like that.
But
So
just in this principle, the heart of this principle is to uh, postpone the decision until it's needed. And in this principle, we say, oh, the software will evolve. Yeah,
exactly,
Mm.
absolutely. We have to keep in mind that at the outset of any either project or sprint or even workday, no matter how big or small the time. At that very moment when we are starting, we know the least. We have the least amount of knowledge,
Yeah,
and as we progress, we gather more knowledge. And oftentimes we get to a point. Oh, if only I knew this last week, I would have taken a completely different approach. And so we need to be kind of humble. And Woody Zuel, Woody's on the panel with us. He said the work presents itself only when we start working.
yeah.
Before we start working, we may sit down and navel gaze and in ivory tower and look at the crystal ball, and we can, oh yeah, I know exactly what. But reality is sobering. When you start working, you realize, and as I say, um, no plan survives the first contact with the enemy. You can have brilliant plan, but as soon as you start executing on it, bam, you just kind of, or as Mike Tyson says, everybody has a plan until they get punched in the face.
But we need to start, but also have feedback. Because if you can start
Yeah,
and we
yeah.
have no feedback between 6 months and you say,
Oh
oh,
yeah,
we,
yeah,
we learn anything from the customer. Yeah.
yeah, exactly. Yeah. So by uh, um, by work presenting itself, it means it gives giving us feedback. But for that, we need to make ourselves interruptible. And I remember I was working on a big project in a large bank 20 years ago, and we went through this kind of. It's incredible. They spent like a couple of months gathering requirements and
Yeah.
uh, paying the expert. Once the requirements document was complete and reviewed and signed off, it was frozen. You
Okay.
freeze, you freeze it, and then it's over to design and coding and testing and
May,
etc.
maybe I think in some industry it's because we have a big contract,
Yeah, yeah.
and yeah.
And then you ignore reality. You froze so you froze those requirements, and then you start working and realize, oh, this is not how we thought it was. But the bosses are saying, no, ignore, just keep charging according to the blueprint.
Yeah, it locks the contract.
Yeah, well, yeah, and so basically you're making yourself uninterruptible. Nothing can interrupt you. You just go in straight line.
But as you said, it's not possible in software industry because it's not like we build a share. The product is not finished at the end. We need it's maintainable at the end.
Yeah,
So we can't use a frozen document. Or
yeah, but for some reason, a lot of people still think that software is exactly like physical object. You
exactly.
you work on it, and when you're done, it's done, and that's it. Thank you very much. You go home, and it still hasn't, you know,
This is wrong. Yeah.
that's not how it is. That's the easy part to deliver the first uh, draft. But now the real work begins.
This
That's
is
what we have.
the danger with AI. Yeah, because
Yeah,
we need to tell to the business guys that we need to maintain after the software.
yeah, and that's why I'm saying my maybe I'm wrong. I could be wrong, but my impression is that AI was only trained on finished product. And AI thinks that from the prompt to the finished product, there's nothing in between. We just go, there you go, right? And that's not how it is. And we need to find a way either to retrain it or, as I'm doing today, find a way to keep it very controlled, very constrained, like you say.
constraint, and we need to deal with also with this new level of abstraction. We need
Yeah,
to embrace this new level of abstraction, but without avoid maintainable issue. Yeah,
yeah, absolutely. And we do have a very solid body of knowledge and practice that has been unveiled for the past 30 years by Ken Beck, and Ray Booch and
yeah,
all these people that are on a round table. We have it. We just have to uh, practice it. It's a discipline. We
yeah,
don't have to invent many new things, but in my experience, if we follow those extreme programming and agile principles and practices, it helps a lot. It's not guaranteeing success, but it really helps a lot. So, may I continue to the next slide?
yeah. Just
Yeah, go ahead.
and in addition of what you have said, we have Ken Beck and a lot of guys uh, that knows the techniques to deal with AI. But for junior, we have a lack or missing opportunities in order to learn from this practice. Yeah,
Yeah, it's a ongoing debate nowadays about juniors and all that. Part of me, because I've been selling this for decades, and I'm always met with resistance.
okay,
People don't like it, and they don't see any reason why should we change, etc. It works for us, and so I've gotten to the point where it looks like it's not. It's like selling life insurance. Nobody wants to buy. Excuse me. But now with AI, there may be a dawning of the new age where with AI people create such mess that we gotta, how do we fix this? And
yeah,
then gives us the opportunity to say, well, okay, now we need to introduce proper engineering practices, and that's the way to move forward. So maybe there is a silver lining on this impeding catastrophe, where a lot of people are kind of fearing that with AI it's going to be a lot of catastrophe, like okay, things blowing up and stuff. So we may be asked to come in and say, okay, Alex and Nicholas, can you show us the way? How do we get out of this mess? And we will present them with the principle we were talking about today, and see if they buy or not. I'm not sure what's going to
yeah.
happen.
But because AI it's an amplifier, it amplifies
Amplify.
the mess and the
Yeah,
all the best practice.
yeah, that's correct. Because uh, the speed of human team, how much damage we can do, is nothing compared to the speed of the AI agents who can
Yeah,
shorten that. What used to take weeks and months now can take few hours to create this mess. So yeah, we'll see how that plays out. It's really early days in my opinion. But you and I are trying to find a way. I mean, what I'm going to show today, maybe just the beginning. Who knows what we're going to come up with, right? People
yes,
like Woody Zuel, and they have good vision, and they will guide us. I'm hoping in the roundtable and in the guild to formulate a much more professional and applicable practices that are have longevity, that have staying power, and will help people.
yeah. We need to
Okay.
see where is the bottleneck now.
Yeah, bottleneck. Yeah, you remove one bottleneck, then the next one, even bigger one. I know. Okay, so can I move on to the next?
Yeah, yeah, we can.
Sure.
Sure.
So again, I tried to illustrate this approximation precision with another. So you have a crew building a sidewalk, and the crew from one corner of the street, they did a really good job. They finished, it's perfect. This crew is finishing their work. It's all precision, beautiful, but they just kind of not aligned. And again, they did not meet frequently to say, okay, which way are you turning? Which way am I turning? I mean, this is a trivial example, but I see that a lot in
Yeah,
big projects where there's a lot of work happening in parallel, and like you say, people are not communicating. Why? Because everybody's like busy. They don't have time of day, right? They just have to keep rushing to finish this. And so this is the problem that we see a lot in complex systems when people are developing some APIs over here and then some other APIs in front end, and they somehow do not align.
yeah. And in your example, we can see this like a legacy or or the other team is not present, and the new team need to synchronize with the other team, but difficult. Yeah.
Yeah, and then there's no documentation because everybody's super busy. Uh, there's no tests because they're like, hurry up, hurry up, hurry up, and then you really have, even if you want to, you really have difficulty understanding, like, well, what talks to what, how do we talk to each other, and yet you are given, a blueprint or a given spec, and you are expected to build it to the expectation, and you are expected as a professional to do a good job by tightening the screws, everything's polished, precise, well engineered, perfect, but it's useless from the from the standpoint of you cannot even run this. Okay,
And
so I want to, yeah, go ahead.
I attend to a DDD meetup on
Uh-huh.
Monday, and it was really interesting to see how we can organize a team to have the whole domain
Hmm.
in his control, and to have this synchronization part at the right point. Yeah.
Yeah, exactly. It's super important. And one thing I always talk about is uh, there's a propensity to optimize. Like if you are running the business and you're executive and the director and the managers and all that, well, you want to optimize, because it's expensive to run the business, and the first thing we all tend to optimize is for utilization, which means
Yeah.
if I hire this crew and they're costing me this much per hour, well, we got to make sure we get money our money's worth. So we need to utilize these people and utilize these machines, and that's always the primary goal. And that is often to the detriment of your business, because I'm always saying we should abandon optimizing for utilization, and we should switch optimizing for value delivery.
Yeah.
So what value are we delivering? And it doesn't matter if some people are sitting on the bench, that's fine. The same is in sports. Like you hire all these
Yeah.
expensive footballers or basketball players, and then you see them sitting on the bench a lot, and that's fine.
Mm.
That's fine. But because the goal is not to always have them in the field because they're so highly paid, they're paid millions of dollars. No, the goal is to score, to win, right?
Yeah.
Okay.
It's the goal of
So
the team.
yeah, the team, yeah, and like I said, to me, the team is the smallest unit of performance, not the team members, right? Excuse me. So I'm gonna quickly just run through some guiding principles, kind of pep talk to understand where I'm coming from. Um, so the first one is we always want to make things good, but before we make it good, it's more important just to make it exist. Just bring it into existence. It's all crooked, but it doesn't matter. You can make it good later. The next one is ugly action beats unfinished perfection.
I see this post in Instagram this week.
Yeah, it's
Yeah.
beautiful. I just want to, remind people of these things. So, you can strive for perfection and it takes forever and don't get anywhere. Okay, this is all crooked and ugly and laughable, but you can use it to climb. And then how much do we learn? We learn this much from theory, but then more from practice, but actually the most we learn from our mistakes. And if we keep everything in our head, it's a big pile of mess, but if we write it down, it's nicely
Yeah.
organized. And before we can get great, we have to be good. And before we can be good, we have to be bad. And before we can be bad, we have to at least try. So that's the progression. And I think often our culture and society expects everything to be good from the first get-go, or else how are you a professional if you're not doing good?
I exactly send this picture to my sister, and
Oh, nice.
yeah, it's very nice picture.
Super. Super. This guy is fantastic. And no, we are now sitting. We have to start. Wait for perfect conditions. I'm not ready yet. We'll start anyway, and it'll be all meandering and messy. But you'll get to your destination. And you know, we think we start from journey to become something, but maybe unbecoming is more important. It's like when a sculpture uh, gets a slab of rock and chips away until you reach the real you, right? You can
Yeah.
move things away from. Um, and always like, well, I can't do this, but then you try to do it, and with all this, like, I can't do it, but you did, you climbing a little bit. And, sometimes we get to some point, but then we
Yeah.
look up and say, oh, wow, look at how much bigger and shinier that thing is. But also turn around, look where you came from. And that's also a wow moment, how much we grew, because we can be at the same time a masterpiece and a work in progress, like the Sagrada Familia Cathedral.
Sagrada Familia.
Yeah. And oftentimes we are hard on ourselves, like, oh, I didn't accomplish much, but it's because we keep raising the bar and you don't even realize how much better you are. So all this is by this guy. I recommend following this guy. Is
Yeah.
such a good, succinct illustrations. All right, so if it's okay, let me talk a little bit about systems development. This is something that I find is being a little bit neglected because we are mostly trained to focus on part of the system and assign roles, but the system itself is a different challenge. So I think the important thing when we're building a system is to establish a baseline.
Yeah.
If we don't have a baseline, then it's going to turn into a big ball of mud. And by the baseline, I mean, like in the amusement park, this is going to, you must be this tall to ride. Meaning, our system should filter, should not allow any substandard thing to enter the system, to degrade it. Once we establish the baseline, it's
Okay.
as I call it, the building code. So if you're building a house, then the government is not going to allow you to go below a certain standard. It will
This is
inspect you.
the foundation. Yeah.
Foundation,
Yeah.
or you have a building code. You have to have uh, fire alarm. You have to have fire extinguisher, and there's certain regulation. It's regulated what is acceptable to be put on the market to not risk people's lives.
Okay.
And same as with any system. Sadly, in software, we don't have that. So anybody can put anything on the market
Okay.
and can endanger others. There's no criteria there. But at least when we are building things and we want these things to perform and are fit for purpose, then I think it's important to draw this line. So okay, this is our bottom line. We don't go lower than that
Okay.
because we want the system to function within acceptable parameters, which means everything is green. That's the only acceptable thing for us. And whatever those parameters are, like I said, depending on your domain, if I'm building something for 5 people that's going to be logging in twice a week, well, these are my modest parameters. But if you're building Facebook, then those parameters are different.
And
And
it's about thinking about the baseline of your business because the system is on a business need, or you mean maybe some practical example, but event storming, something like that, or
well, you have your system, it's in operation, it's live,
okay,
people are using it, it's making money, and we need to have some description, some parameters that say, okay, I'm only okay with my system if it's within these parameters. If it's not within the parameters, then I will be concerned, right? So how do we do that? Automation. So we have 3 phases. We need to automate the observation instead of
okay,
having people 24 by 7 staring at the screen and observing it. That's very inefficient, and people are prone to making mistakes. They go to the bathroom breaks. It's better to have automated. The system must be observable so we can constantly monitor it, the health, the heartbeat, etc. It's up and running. It's not crashing. There's no bottlenecks or traffic jams, etc. And then also the automated detection. There's got to be a way to detect pathological behavior. All of a sudden, something people are trying to order and it's refusing. There's bug or something. That also is better to be automated and detect, blow the whistle. And then also the next phase is once we detect something, the intervention. So the intervention must be also hopefully automated as much as possible until such time when it needs to be escalated to human operator.
okay,
But the detect the pathological behavior systems are not operating within acceptable parameters anymore. Now we need to intervene. We cannot just say, "Oh, what can you do?" Who cares? And
So
then that yeah.
we need to figure out or think about this baseline as a higher level in before start the system.
Yeah.
Yeah.
Or as we're growing the system, it changes.
Okay.
As we're learning about our domain, and but it always has to be there. We cannot fly blindly, and then imagine flying an airplane and there's a wing on fire, and the engineer don't even notice that. You got to be able to detect and intervene as soon as possible, and automation is the key there. So that's basically at the high level. And then another thing that I'm really big on is what I call time to hello world in production. This is a very trivial thing. Basically, let's say, you can walk into an organization and say, let's say I have a hello world HTML static page. How long does it take for this page to show up in production?
Mm.
And this is going to tell you a lot about the health of that. Uh,
This is a lead time, no? Metrics
yeah,
in the DORA, yeah.
yeah, yeah. But because this is devoid of any, nobody can raise any security concerns or functional concerns like, oh, we haven't tested it really. Blah. No, you cannot slow it down. It's just a stupid static page. How long does it take to push it to production? You'll
Okay.
be surprised how in some organizations it takes very long time and a lot
Yeah.
of rubber stamping, and so that exposes that this is a infested with unnecessary ceremonial works and meetings. And because to me the health of the system, CI/CD pipeline is feature zero in any system. So the first thing to establish is CI/CD pipeline, fully automated, that can, in a matter of seconds, make this hello world page show up in production. There's no need to stop the proceedings to have inspection gates and all that. Once we have that, we at least know we have this kind of a cardiovascular system, or the artery, the main artery pumping blood. It's very important to have that in the system, to have that process that is a non-event. It's a non-event. Nobody should be losing sleep or, oh my God, so we're launching Hello World in production, and everybody's like going like this and hoping that the pager is going to go off in the middle of the night. So that's a very important parameter, and I find it oftentimes it's surprisingly big deal. And for many organizations that I find, deploying anything to production is a major event, and everybody's like
Yeah.
really trembling. Oh my God, it's going like this, and hoping things.
Not on Friday.
Not on Friday. No, don't ruin my weekend, etc. That should not happen. So that this is the healthy system that is calibrated to always function within acceptable parameters. And if something breaks, we have observation, detection, and intervention. Close the loop quickly, back to the healthy state. This is number one. This without that, we are flying blind. We are just kind of flailing. So that's the pinnacle. I mean, the first step in quality engineering. The next step is,
But just
yeah,
it's easy when you have the controller on the roll process, maybe on startup or something like that. But I think in some teams, people want to diminish or tends to diminish this lead time, but it's not possible because you have some another team. You have not the control on this team, and imagine you see that you have a big lead time. What is your advice for people in order to impact the lead time on the other team? Maybe they can show the business value to have to deliver and make that it's not an event to deliver in production.
it depends. I often mention, I don't know if you've been involved, but I've been involved in other situations. The so-called all hands on deck. The business is flying and everything's cool. All of a sudden, some major crash. The Some important whale customers are screaming. What you see next is the CEO and everybody's on the floor, all hands on deck.
Yeah.
Drop whatever you're doing, fix this. At that moment, you see that all the inspection quality gates, all the ceremony falls apart, and people just go there in a matter of minutes, bam, 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 it's fixed. They know how to fix it. So the system is lousy, not people.
Yeah. Okay.
Okay. So that is diagnosis. You can diagnose the system by that. How come, when you are doing regular process, it takes forever and it's all like pulling teeth and I don't know, deliberation and everybody's check and check again and recheck and all these things. But when the crisis hits, bam, 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 it's fixed. So I advise people to then analyze that process in the crisis and see how it works. And obviously it works. And then adopt that as to become a normal, regular way of working.
Yeah.
And that way, I think it improves the health of the system. And what they say: if it hurts, do it more often. What we see is in my one of my previous projects, there was a overseas team who was building something, and there was a flagship product that was supposed to make a big splash on the market. And because of the not respecting approximation before precision, when they launched, there was a big crash,
Yeah.
and everybody got burned real bad. And the bosses issued the edict saying, okay, from now on, we will deploy only 4 times per year.
Okay.
And then as each deployment was approaching, the paranoia was insane. There was like endless meetings day after day, checking everything, rechecking, rerunning. Meanwhile, the batches were getting bigger and bigger and bigger. And so after 3 months of like moving around and when you deploy, the blast radius is potentially huge because it's a
Yeah.
big change, right? You never know what the edge effect may be. And so this is the opposite. This is like if it hurts, do it less often.
Yes,
And
and this reduces the innovation because people are fear to add some features or
nobody wants to touch anything. And then a lot of paperwork because paper takes anything. And if you mess things on paper, you're like, oh, sorry. And then nobody wants to touch the code because it's so it creates this logjam and paranoia. And to remedy that, it's like increase the frequency, do it more often. And and,
like
and
this. You have more opportunities to fix
yeah,
along the way. Yeah.
yeah. And even I recommend even doing daily deployments, even if there's zero diff. It's exactly the same as yesterday, but you do it today just to see that this pipeline is just working, everything is all the
Yeah.
arteries are clean. That way you relax and you don't have to have this super duper okay, triple double check, triple check. Did you check? And then endless meetings and spreadsheets and checking green and yellow, and it's just counterproductive. So again, abandon hot fixes. Hot fixes are bad smell. If you have an organization with hot fixes, something is broken.
Okay.
Every whatever it is, it's a regular deployment or fix or some emergency, should have the exact same regular process. No big drama, no big, oh my God, I hope it won't blow. That's a system function within acceptable parameters. It's very important, right? Okay, can I go to the next?
Yeah. Yeah. You can.
So the next one is a so-called walking skeleton. And again, we see that a lot, that people start working and everybody's assuming, but by walking skeleton, I mean all the pieces of the infrastructure that we know we're going to need persistence layer. We're going to need network connection. We're going to need and API endpoints. We're going to need CLI interface. We're going to need maybe voice activation, whatever it is, mobile. So all these pieces of infrastructure, to put them together, you need to, of course, sort out the API keys, the secrets, the
Yeah.
passwords, the tokens. So before you before you start adding any fluff and any fancy schmancy functionality, make sure that all these things are talking to each other. Without any, there's no feature, there's no functionality, there's nothing useful, but at least they're up and running. All the API keys, all the tokens, everything is sorted out. You're connecting to the database, no problem. You're receiving input from such and such device. That's walking skeleton, sometimes also called ports and adapters, because oftentimes we see these things haven't been sorted out, and then we go live and there's no SSL keys, those things, digital rot, right? All of a sudden that something blows
Yeah.
in production because we didn't even try the walking skeleton. So I would suggest that first step, time to hello world, it should be non-event. Walking
That's the
skeleton.
integration, is an integration of each component.
Yeah. Integration of the infrastructure. Integration of the functional components is a different topic, right? Because now that you have this running, this is hosting some code and some protocols that need to talk to each other properly.
First, the infrastructure. Yeah.
Yeah. So just bare bones skeleton with infrastructure. Then you will add some muscles and organs and blood vessels and skin and hair and makeup, fancy shoes, robe, etc. So these would, to me, be for me be signs of a healthy system. That anytime you, I apologize. Anytime somebody approaches the team and says, "Okay, what you're working on, we should be able to stand the system up and show you, even if it's bare bones, but something is up." This brings me to hexagonal architecture, and I never know how much people are familiar with that.
Yeah.
But I will talk briefly about it. So when I say hexagonal architecture, and maybe people envision something like this, and no, we're not talking about that. We are talking about what Alistair Coburn, he invented this, the ports and adapters. Basically, to simplify, it proposes an inner core competence layer, which is the domain, the application core. And then this core is surrounded by the outer imperative shell, which is the external world representing UI, databases, APIs, command line interfaces. And these are sorted with adapters and ports. I'll talk a little bit more about that. So to demystify, I'm trying to demystify and illustrate, I use this example of a pizza shop. So in the inside the kitchen, you have the organization, the core, the secret sauce, the chef with special sauces, and also not only the chef but the manager who is organizing shifts and promoting people and organizing company picnics and who is going on vacation, who is sick, who is not. So that's all inside, hidden from the outside world. On the outside world, we have on the left hand side, we have these ports, or we call them drivers. So these are the events that are going to agitate the system. If nobody walks to the pizza shop, the kitchen is going to be idling. Why make pizzas just to make pizzas? There's no point in that. So the system can be triggered either by somebody walking to the shop or going to the order window or phoning or online using the phone app or logging in on the web and say, okay, I want such and such pizza, pepperoni, etc. On the right-hand side, we have the adapters, which is recipients repositories, which is the order fulfillment, delivery, pizza delivery, and then also receiving supplies, etc. So that's, in a nutshell, I would say a very trivialized hexagonal architecture, where the goal is to maximize the core, the inner is the actual business value. The outer imperative shell is a commodity, meaning every business has it. If you have it, you are not competing on that. You cannot say, oh, we enable our customers to order on the phone. Well, every other pizza shop has it. So that's not your competitive advantage. Your competitive advantage is in the inner core, where you have your secret sauce, how you manage your business, and that or your marketing, your advertising. This is your secret sauce to success. Okay, so can I move on now?
And yeah, just in addition, the goal of the hexagonal architecture is to not have contamination, inside your domain. And the goal is I think most people think about the hexagonal architecture and clean architecture, but you can just set up the hexagonal architecture without complex things like DDD or clean architecture. I think it's a best practice to just set up the hexagonal architecture. It's more easy than complex things like DDD.
Yeah. basically, and thank you for reminding me. I should have said that, but I forgot.
Ah,
It's the true. I mean, the best name for this architecture, I think, is configurable dependencies,
yeah,
because there's no every system depends on something. It's it's impossible to design a system that will be not just on its own, sitting in a bubble. Huh. It is these dependencies, as somebody says, the problem with dependencies is that you cannot depend on them.
yeah,
And so it is the dependencies that are causing trouble and are bringing grief to our profession because they keep shifting, moving, things start breaking. We establish, we pull in some dependency, okay, our system depends on it, calls it, everything's cool. You wake up the next morning, okay, something changed over there, our system is dead. Uh-oh, okay, so now we are really hostages of these dependencies. So
it's a
it's somehow like,
fault tolerance. Yeah,
sorry?
it's like a fault tolerance. You,
Yeah, exactly. And so this architecture proposes to minimize the coupling between
yeah,
our business, our operation, and external commodities. If we're not respecting that, we will quickly find ourselves tightly coupled
yeah,
with third parties. And now our system is extremely brittle. Something changes, everything breaks down. Right? So you have to say we need to build a resilient system that is gonna roll with the punches. So they call it configurable dependencies, which means we can configure them and we can plug in, unplug and plug in something else. And when we do that, the inner core or the domain is not aware that anything changed.
yeah,
To the code inside the core, everything looks always the same because the the domain is not aware of anything that is outside, has no idea. It just knows that, hey, I received these values, I transform them, and I communicate transform values over there. It's purely functional.
yeah. And by figure out the boundaries, you can also it's an opportunity to make anti-corruption layer, from a system.
Exactly. Anti-corruption layer. You really, again, you want to detect any pathological behavior and intervene.
Yeah,
And if something is down, okay, plug something else, keep the business going. Or worst case scenario, graceful degradation. And maybe something is down and you cannot find a replacement, but you keep
yeah,
chugging. You just degrade your capabilities, but you're still up and running. You're still
yeah.
explaining to the customers, bear with us, etc. Try this, try that. You're never Titanic that just goes down
You
100%.
you're able to respond to the customer.
Yeah, you are always up and running, right? This is called graceful degradation. Okay, thank you. So, uh, in in my world, this is how I would. You talked about boundaries,
Yeah,
and it's important to establish boundaries. I kind of a very broad strokes. Five boundaries. The first one is the boot or life cycle domain or responsibility or concern. Then defining some capabilities, the external interaction, business policy rules, and the orchestration. And we can, yeah, this is a convention. We can change that, but I like to leave these things to live in the source area of the repo. The lifecycle boot is in the app. I'm using Node,
yeah,
you know, in the app, and then there are ports, there are adapters, there's a domain where we want to keep things not coupled, and then the orchestration is the in the application. So it's very simplified, but like you say, these boundaries should we should have a mechanism that would observe changes and will detect the violation of the boundaries and will then intervene.
yeah,
So to keep our business chugging and our system up and running, I think we need to establish some really hard rules, not the line in the sand, but really hard rules, and these things should never break. Now, we can now move on to unless you have any comments on the approximation work. No?
No, just for the boundaries.
Uh-huh.
Technically, we have also some tools in Java because I do Java, like ArcUnit or Maven plugin in order to respect this architecture, the repository. I think. Yeah.
Oh yeah, yeah.
Mm.
And I can tell you from my experience that if we are not careful, the AI will violate these boundaries.
Yeah.
I've seen that. And for some reason, it does not, unless you really explicitly, you have to be, and I don't know, I don't have the silver bullet, but if you don't make it really explicitly aware of that, it will just go and just completely ignore this. And that's where the trouble begins. And if people are not aware of that, they think everything's fine, everything's working. So yeah, there's a hidden danger here, the minefield that the AI can push you into this kind of. Before you know it, you find yourself in a swamp area, and then you don't know where the quicksand is, where the crocodiles are, and you keep going. That's the danger with zero shot prompts and all these things.
Yeah. You can
You
ban some import on some folders. Yeah.
yeah, yeah. So at least make people aware of those things and the fundamental importance of respecting boundaries. So precision work. So now let's say we have established, time to hello world, to production, the walking skeleton, everything is running. We have the established the ground rules that the core is completely uncoupled from the outside world, doesn't know anything about the outside world, and then we can play around with those configurable dependencies. Now let's move towards what's happening inside the core domain. So
Yeah.
this is where the precision, in my mind, the precision work happens. This is where you actually add value to the business. So all these things are not adding any value to the business. Everybody has those. These are commodities that you cannot compete on those. I think you only compete on the precision work, right? But as I'll try and show you later, as we are progressing with the precision work, we have to constantly keep checking if everything is still hanging together
Yeah.
and if no boundaries have been violated and all that. So that's the discipline. That's something that if you're hoping that's going to spontaneously happen, especially with AI, but also with working in teams, people, people are busy. They ask, okay, can you make this? Can you fix that? And just go and make some changes and don't even realize that they have crossed the boundary or they have introduced tight coupling, and which later is very difficult to uncouple, to decouple, right? Okay, so
And you know
already,
your business value also by figure out the boundaries and the precision work. You know the business value of your domain.
yeah, exactly. So this is where we are actually earning our stripes. I think that we can implement secret sauce or something that differentiates our business from our competitors.
Yeah.
Like if there's people think it's all the same. No, I mean I worked a lot in fintech, and every bank, they have their own policies, they have their own ways of dealing with customers, and it's unique. And oftentimes it's a secret. They don't want to expose it to others because that's how they make their riches, right? And this is where it happens. But for this to actually work, we need to protect this inner core jealously, keep it, guard it, hide it, lock it.
Yeah.
Because if it gets, like you say, if it gets infested by other things, next thing you know, you have a rat's nest. People going, okay, what do I change? Afraid to touch this, afraid to touch that. And then, I can tell you, I worked in large banks and big projects, and I interacted with brilliant people. There's like chief operating officers, really smart people, and they tell me that their biggest harness or the biggest frustration is software. They're not happy with software.
Uh,
They feel the software is the one that they have been given to automate their operations is debilitating. It's kind of tying their hands, and yet when they go and ask for help, everybody's sort of like, "Ooh, I wouldn't advise touching that. I wouldn't, keep the sleeping dogs lie and all that." So that's what I'm saying. Like there's a big, I see everywhere I go, I have big hunger for quality software. People are hoping, can somebody walk in and give us something that really describes our business, that really fits our business? using those SaaS, or ERPs, they're not happy with it. They feel they're cornered. He says, I'm losing so many opportunities because I'm forced to do things this way because the software is so rigid. Meanwhile, he's smart. He knows how he would do it much better, but he can't because he. And now the danger is, but with AI, maybe they think, okay, now I can do it myself, do the vibe coding.
Yeah.
So anyway, all right. So what I like to do sometimes, I don't know how many people know about zombies, because in my mind, if we are going to do a good job in all these things, we need to be very, how shall I put it? We engineers are very optimistic by nature. Like I get up in the morning and I want to build something, and my focus is I'm excited. I want to see it work. So I'm focused on success. But what I learned in my practice is much more important than that is to be focused on failure. So failure is very important in software engineering, and I think it should be promoted to a first-class citizen.
Okay.
Some people really disagree with me on that. So this is not, maybe I'm in a minority, but I think that in software, failure should be center stage. So what I learned throughout years is whenever I want to make a change, I always start from a broken system. I like to break it. I see it broken, and then I fix it.
So you like cow engineering?
Yeah,
Yeah.
but because otherwise, if I'm building and everything seems to be working, this is deceptive. I'm just seeing it from the surface. And so, you have, oh, it works on my computer. Oh, and then you put it in production, doesn't work.
Yeah.
So I think it's very important to first start with the breakage, with a failure. Something is
You
broken.
you anticipate some behavior
Yeah.
like this.
And when I teach that and teach courses and workshops, and then people who are not experienced are like, okay, Alex, I understand, but what I don't know is like, what is so we break things by writing a test, which is executable expectation. This test expects the system to do something, and when it runs, it fails because the system doesn't do it because the system still yet doesn't have that capability.
Okay.
And so I'm saying, first write the test, you expect something, you run it, breaks, fails, it's not there. Now you roll up your sleeves, now you make it there, and the test passes. And you,
Yeah.
you go like that. So this is TDD. And then people complain, okay, that's fine, but I don't know what's my next test. I have no idea what to write next. And so James Granning came up with this zombies formula, which breaks it down. It's an acronym. Okay, first start with 0, which means, all right, so your system, let's say you're expecting your system is taking orders. First test is like, how does the system behave when there's no orders, like 0, empty? There's nobody ordered anything. And the test will agitate the system somehow, and the system should respond with some kind of a message. And so you write this test, you run it, and you see it fail. Then you go and you make it pass.
Okay.
Okay, so at least we now know how the system behaves when there's nothing there. Then move on to O, which is 1. Okay, so let's say there's a 1 order. Now, how does the system behave where there is 1? You write the test, you run it, it breaks, make it pass. Okay, move on to M, many. Okay, now when there's 2 or more of these things, what do you expect the system to do? And on and on. Boundary, what happens when you hit some kind of a boundary, maximum, minimum, etc. Then the interface, how do we present it to other components? The exceptional behavior, when some pathological, unexpected happen, what does the system do? Let's run through some simple scenarios. So this is like a mnemonic or a guiding principle to keep in mind if you sit and I don't know what my next test should be. Think in terms of these zombies.
I think we can find some example on the web, but it would be interested to have an example of an implementation with each case. Yeah.
Yeah. And yet, this is yet another way to constrain the AI. instead of telling it, okay, just go and do this, you break it down into those smaller
Yeah.
steps. Let's first let me see what you can do with zero, like to build something that's going to respond to when there's nothing there, and one, many, etc. Okay, so what I kind of discovered last year, it's about a year ago, when I was working something I call test-driven navigation. Uh,
Yeah.
and I basically what I was doing your classic TDD with AI in the loop. And then I realized as I was doing it that actually I am turning into a navigator. It's kind of like, if you're in a car and your body is driving and you're holding the map and now you're navigating, you're telling the driver, okay, now turn left and now, stop over here, blah, blah.
Yeah.
But you are not necessarily checking how the driver is driving. You're not saying, okay, step on the gas, now step on the brake. You leave it to the driver. And you also leave it to the driver, the maintenance of the vehicle, fill up the gas and change the oil, etc. But you are sitting there deciding where to go, etc.
Like a
So,
copilot.
like a co-pilot. So the first thing like I explained, I like to write the test that fails. But now instead of me rolling up my sleeves and writing, making some changes to make it pass, I give it to the AI agent. And it's okay, check this out. This is failing. What are you proposing? And then it goes, looks at it, and maybe it stops and asks me, "Hey, I want to do this," or I just do it, and it makes the test pass. Now, I may ask it to refactor to improve the design or not. This is now my call. And so we go in small steps. I may validate how things are going round and round. Um, with kind of three pillars here. The first pillar is test first thinking, which is what to do next, how to break the system. And then I also like mutation testing. And I don't know how much familiar people are with mutation testing. To me, this is the indispensable tool.
Yeah. Because
And
100% coverage
no,
is
it
not,
doesn't happen. No.
yeah.
And especially with AI, because AI, like as we discussed, AI has this propensity to go and bloat.
Mm.
And you may not even aware how much crap it populated in your repo. But if you run mutation testing, it will dig it up and it will say, what
Yeah.
about this? And then you can decide. I think it's on you to decide. Do you want to keep it or do you want to say, what, just let's chuck it. This is completely unnecessary. So keeping it lean and mean is very important. And I find that mutation testing helps a lot.
And when you execute the mutation testing phase, yeah, it's
Uh, that's a good question. It really depends, and it can be calibrated in different ways. Our friend Paul Hammond made some
yeah,
inroads there. I still haven't had a chance to really delve deep into it, but it is a costly operation, especially when you have thousands of tests and big repo. Uh, in the earlier days, I was leaving it overnight to run, come in the morning and review the report. If we can, I mean, just yesterday I was running with the agent and it created, I think, the mutation testing found 27 surviving mutants. And I looked at the report. I was like, oh, this is going to take me hours to fix.
okay.
And I just tell it, look, we have some mutants. Can you take care of it? And just went by itself, found the report, fixed everything. Amazing, because I can tell you, I was running mob programming sessions, and we were doing TDD and building the system gradually, and at the end of the session we ran all tests are green. Everybody's like, yeah, and then I go like, okay, let's now try mutation testing. Like, what is that? If you run mutation testing, surviving mutants. Oh, then people sometimes take it personally, like, no, 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 you got to fix that. But sometimes it's not easy to kill those mutants in my experience, right?
Yeah.
And I find this AI to be very, from what I've seen so far.
But like you said, if you're interested, at the end of March, Paul will try to show how he in a meetup he tried to show how he use mutation testing in a small step instead to launch on
Yeah,
the pipeline. Or I will be interested in this part also. And
yeah. You go ahead.
just for the right test phase one, do you use the zombie acronym?
Uh, as much as it can,
Hmm.
but not always. But it helps, because it gradually. I mean, you're growing your system gradually, and you are kind of you're stepping on every stone. You're not skipping stones in the hopes like, okay. So it really kind of establishes, okay, we have defined how the system behaves where there's zero, whatever. We have defined how the system behaves where there's one. We have defined how the system behaves where there's many. We have defined how the system behaves when it hits boundaries. We have etc. etc. So all these bases are covered. You can now go further, but at least you have your regression baked in. And so moving forward, if AI or somebody messes with that and changes the detection, the test where blow the whistle, and you're like, okay, he breaks the pipeline,
Yeah.
breaks it, and you have to go back to the drawing board and fix it. You won't be able to proceed. So these are you must be this tall to ride. These are the bare minimum. If I would say if any of the tests fail, okay, the deal is off. Back fix it. We can be even more hard ass and say if there are any surviving mutants, the deal is off. Kill them. Right? But that's pretty intense, right? But if we're kind of lax and we're like, okay, yeah, then it's not. I don't think it's professional engineering. It's mostly like amateur pet project, etc. So to me, I find the best way to keep AI constrained is by feeding those tests. Now, some people, and again, I'm on the fence on that. Some people say, well, you can just give it a prompt and it will write all the tests and all that. And I still like to do things manually or
Yeah.
semi-manually. I may ask it to write a test, but then I will review the test.
Yeah.
Um, I may not, and then when I give it the test and makes it pass, I may or may not look at the code. Because sometimes if all the mutants are killed and all the tests are passing, yeah, the code is probably mediocre, but what's wrong with that? The perfection is the enemy of good.
Yeah.
That maybe I'm wrong, right? Now, one thing I want to add here is that I've seen AI, and unless you really know how to work with it, I've seen AI sometimes in a pickle when trying to make tests pass. So it makes some changes that makes the new test pass, but it breaks the old test, previous test that used to
Okay.
pass. And what AI sometimes does, and this is very important, it can go and modify that test to make it pass again. This is
Okay.
this is illegal. And so so that's what I'm saying. Like, if you don't know what you're doing, it can really trick you, lull you into, oh, everything's green, everything's cool. But then when you go and look at the test, like, wait a minute, you changed my test. You
Yeah.
you change the assertion. Why? Because it's been trained to be success oriented.
He
It's
breaks the
been
rules.
it's been trained to make all tests pass at any cost. This is the danger.
Yeah.
And so, I still am skeptical that non-technical people can just go in and use AI and build sturdy applications.
It's a rule. It's a rule like you tell to a team, you use a metrics on a team to see, oh, you need to reach 100% coverage, and what is the law of this? I will tell you what is this law. And think it's what you describe with the AI. It tends to reach the target because it's a metric.
Yeah.
But when the metrics become a target, it's a bad metric.
Yeah. Yeah.
It's a good art law, I think.
Yeah. And
Yeah, okay.
I've seen in previous years without AI, I've seen situations where the team is working and all tests are passing, and I go and I examine the test and I see some assertions have been commented out. And I'm like, what's this? And they say, well, we were running and it just keeps failing and we couldn't make it pass. And I'm like, why is that? Well, because the test had some temporal dependencies. Like this test needs to run first in order for that test to succeed. And in the pipeline, they're randomized and they just keep crashing. So they commented out. So that right there, you see that this is immature team that doesn't know how to write tests, because no, each test should be completely independent of any other test. It should not
Yeah,
depend on this one runs first and the second one runs first. Or as Kent Beck said, if the order of operations in your system matter, it's not a good system. The order of operations should not matter. You can run them in any order, it should work. So, but
yeah.
that's, we see
Yes,
that a lot.
but for humans, you care about the process. But for the AI, I find it good at low. It's an adage of on state as when a measure becomes a target, it ceases to be a good measure. But if in his target you have the test should pass, yeah, it can
Yeah,
violate this good at low. Yeah,
yeah. So again, a word of warning to people who are using AI: try and browbeat AI into agreeing that it is not going to modify the test.
yeah.
If I give it a test, then this is now, unless I decide to modify it, AI should not have that liberty. But I've seen it happen. It just goes and changes everything.
Need to have
it,
constraints, yeah,
yeah. All right.
or guardrail.
Roger. So demo time. How much time do we have left? I don't have. This is good.
Do you think you need maybe 20 minutes? It's okay. Yeah.
Let's see. Okay, so I'll try and rush through this. So I kind of propose we build a very toy-sized, something like conference scheduler, right? So for that, um, I am going so to save time, not to type, I'm going to copy and
Yeah,
paste some of the prompts, stuff like
sure.
that. So what we have here is a system, and tell me if the font is large enough. Can you see
Yes, I see the ID.
is the size of the font large enough, or do I need to make it
Yeah,
bigger?
yeah, it's okay for me. Yeah,
It's okay. All right. So we have a simple repo here with store src and tests, and I have some those MD files,
yeah.
like the agent, the architecture, and the testing strategy. And so here I'm emphasizing this. Sorry. Uh, if you ever get an idea to modify any test, stop and let me know why you feel you need to modify a passing test,
Mhm.
and wait for my explicit approval. Because before that, he was doing all kinds of shenanigans.
Yeah,
So the ground rules are making the test as simple as possible. If they're writing the test, if I give them the permission, no conditional. This is one big problem I see in many tests, that there's a conditional logic, and that is not a good test. Okay, so let's the initial prompt. I'm saying we're going to build a conference scheduling app. I tend to structure the app following hexagonal architecture, etc., etc. So let's just run it just to make sure it understands.
you start from
And
scratch. Yeah, the app is starts
yeah,
from
yeah,
scratch. Yeah,
I just see. Okay, so
so maybe we can have the demo with a legacy.
yeah, well, here as you can see, the source and the test. So the adapters are empty, application is empty, test architecture is empty, domain is empty, ports are empty. And same is here, adapters, application, domain, ports.
Yeah, okay.
JS app, I'm going to delete it. So everything is empty other than package.json, striker configuration, node modules, and these MD files. Nothing else there. And I ask it to review, and it says, okay, it says current project shape is a minimal hexagonal scaffold. I'm ready to follow your TDD flow. You provide failing test, and I'll make the smallest change in SRC to pass it and refactor only when requested with test screen. Okay, it sounds like an obedient team member. See how far we get with this guy. So the first test, I'm going to, I call it outside in, the application boot test in the architecture folder. And I'm going to just copy it, not to type. I'm sorry. So basically, all says like expecting the application to boot without crashing. When it requires the src/app, it's not going to throw an exception. We run the test, and it failed.
It failed.
I like to see it fail. I never trust, as Tim told me, never trust a test that you haven't seen fail.
Yeah.
It can be whatever. So we cannot find the module, right? All right, so now let me copy the prompt.
Just for attendees, it's to avoid false positive, you know.
Yeah.
Also.
Exactly. Oh, thank you. No, please chime in. So I'm saying implement the minimal app.js required to satisfy the failing boot test. And constraints are: do not add business logic. Do not introduce express or external frameworks. Do not create additional modules. Just export something that allows the module to be required without throwing. And codex is working. Prepare the minimal.
You use codex again.
Codex, yeah. I've been experimenting with codex in the past, just this week, because I keep hearing good things about it, and I'm like, let's check it out.
Yeah.
Okie doke. So we go here, and we run the test again, and it passed. And of course, when we look at integrated app.js with the export, just no brainer. So see, we're going really, really baby steps. The next one is we want to establish that the ports are there. So I'm going to create another test here. Port exists, and this is going to be our second test. Basically, it's expecting to find SRC ports and to have property schedule session, but it fails because it cannot find the module.
Yeah.
Let's prompt codex. I mean, these prompts are already verbose. You can be more succinct, but so the constraints are no implementation logic, no dependencies, function body can be empty. It is searching, exploring, assessing, creating minimal ports module. It's
okay, you put constraints each time.
Yeah, and it now claims that all tests are passing. I'm gonna run it again because I'm paranoid. Okay, I see that. It's created index in ports. There's an export and schedule session function. Cool. And I think we can close this. Okay, moving on. So we're progressing in excruciatingly small steps.
Yeah, we test the infrastructure, you know, for the time being.
Yeah. But you know, at the same time, we are baking adapters. We are baking our regression. So from this moment on, whenever pipeline runs, you're going to run all these tests. If anything's broken, the process dead stops dead. So we're now in adapters, right?
Yeah.
writing the test for the adapters. These are all like very simple declarative tests. It just says, okay, I want to see in SFC adapters the HTTP adapter to have property schedule session. It fails because it cannot find the module. Let's prompt it. I could have made those prompts simpler, but I just want to. So we are saying create the HTTP adapter, no express wiring, no HTTP server, no real logic, just satisfy the contract. We want to keep it really dry, bare bones. To me, that's the safest way to proceed. And we're gradually adding more and more juice to it. Okay, so it claims it's passing. All right, so the adapter here, schedule session. Okay. Moving on to the next one, which would be walking skeleton.
Walking skeleton, yeah.
In architecture. I'm going to build walking skeleton expectation in the architecture. And the test is, again, very simple. Oops. So it requires super test and attempting to post at the endpoint sessions, sending the payload title test and expecting to get back the HTTP response status code created 201.
Okay.
This must fail. I'll be shocked if it doesn't. Right. So app address is not a function.
But just for the attendees, it's to go faster because you copy paste from the document. But your method is to write the test and the assertion and ask to the AI to implement it.
Yeah, exactly. Now, to be clear, some of these tests you can write by hand, or some of these tests you can prompt AI to write for you, and you can review and accept or not. So it's pretty good at writing tests, these simple tests when you prompt it properly. But sometimes I like to write craft by hand, right?
Yeah.
The important point is that it should always be reviewed by a human, the test. Code, it's kind of, sometimes you can not review the code, or maybe you review it later. It's not mandatory, at least for me. But the test, yeah, I like to review the test. So
you need to have good assertion.
yeah, of course, because meaningless assertions, test pass, and then means nothing. But then mutation testing will catch it later. Okay, so it's working. It's adding some stuff here, implementing, running, and confirming. So basically, we need to check again. All right, and see, it was adding things to the source app. Yeah, see, it's posting to sessions and returning 201. Excellent, good job. Moving on to, now we want a skeleton, walking skeleton is up and running. We want it to accept some input. So again, in the architecture test, I'm going to say okay, the system should be able to accept external JSON. We put some values, and the payload will be hello skeleton, and the request will be sent to the input endpoint by sending payload, and then we expect to get 200, okay, as well as the body, there's HTTP response to contain the payload. So we're just kind of bouncing back.
And just at this step, because usually I work with OpenAPI or something like that, also in front side sometimes, but we can generate the input, the object, thanks to the OpenAPI contract also, at this step.
Yeah. I mean, I'm just keeping it really, really bare bones, no brainer. For the purposes of this demonstration, this is all toy size. All right, so it fails, of course, because it was expecting 200, got 404.
Yeah.
And let's prompt it. Make the failing test pass, minimal implementation, no validation, no domain logic, just keep it bare bones. Echo it, accept the post and echo it back. Did I hit enter? Oh, I forgot. Okay, it's diagnosing the failing test. After inspecting it, found the contract, edited app.js, adding route, and made it pass.
Yeah.
Okay, excellent.
Amazing.
Amazing, yeah. Smart. It's a glorified autocomplete. I don't think so. Okay. We are moving now to another walking skeleton test. I wanted to also demonstrate that it can include a persistence layer.
Okay.
Persist the session. So again, in the architecture, I'm going to add a new test where, okay, so it's saying basically it requires source adapters persistence in memory session report. So the simplest in memory, no infrastructure still. And
Yeah.
we are going to expect the ping to be Pong. Okay. It will fail because, yeah, I cannot find the module.
Yeah, sure.
Yeah. But you see, we are now kind of building those boundaries and making sure that everything is firing on all cylinders. We are saying minimal implementation again, no database, no domain logic.
But he will add at the right place
Yeah.
each part.
And it could be, again, configurable dependency. Maybe we're okay for in-memory for now. And then later on, we may just add some auxiliary persistence. Okay, so it says made it pass. Okay, so in the app, oops, sorry. Moving on to health check. We want to have a health check. And this is, again, observability.
Yeah.
And to make sure
It's already exists at this location. So yeah.
what did I do wrong here? Walking skeleton test.
Maybe it's the name of the test. No.
Sorry. You just add it to the
Add.
walking
Okay.
skeleton. Yeah.
Mhm.
No need to. Yeah, just add it here as a new test. Fails because it was expecting 200. Let's prompt the agent. Okay. Minimal implementation, no additional features, no validation, no new dependencies. We want to have the endpoint health, which if it gets reached, it returns 200. So we know the heartbeat, the system is at least up and running, if not doing anything, but at least.
And if you need a library to make it pass, the agent will ask to you if he has the right to add the library
Yeah.
or in the package. Okay.
Yeah, it's not allowed to add anything. And it will stop and ask, and I will say yes or no, or I will say, okay, change of plans. So yeah, very
Okay.
important. So yeah, prime directive, fight bloat with all your might. Like, don't allow bloat. It will pretend to know everything. It was super smart, and no, just treat it like a little kid in the kindergarten. Like, nope, I told you this, and stay on the straight and narrow. Don't come up with fancy ideas. That's how I work. Some people, the opposite. They're like, okay, hit me with
Yeah.
your best idea. Yeah, okay. I mean, but can you now maintain that? Will you be able later on to defend it when somebody comes and say, what's going on here? Like, well, I don't know, this AI did it. Well, that's not, that doesn't sound very professional. But you're
And
right. Thank you. Yeah.
and in my last meetup, we see that sometimes he loads too much MCP data, and he consumes some token at the beginning because he load everything.
Oh, yeah. That's, that's another conspiracy theory. Okay. Another thing we want to do with our architecture layer is uh, another important test, which is, I'll just briefly, a bit more involved. Okay. We want to make sure that in our inner core, our domain, the core competence layer, we are not introducing, or what's the word? There's no infestation.
That's not
We are
dependent.
not introducing any commodities. So here we have a list of forbidden libraries: Axios, Node Fetch, HTTP, HTTPS, XML, HTTP request. We are
Okay.
putting down our foot down and saying this is the ground rule. Anytime anyone makes any change to the system, I want to confirm that I don't see any of these libraries in the domain, SRC domain. And it's doing it by scanning, and there's many ways to do it, right? So we're expecting the scan not to throw exception.
Okay.
So now, what do you think is going to happen when we run the test? Is it fail or is it going to
It's
pass?
because at this time you have no import on the part. Like maybe it will pass. But
Let's see. Yeah, you're right.
okay, okay,
It has no reason to complain. The test is health. The system is healthy within acceptable limit parameters. So we are cool. So now, again, my pet peeve is this false positive?
yeah. Maybe you try to add an import.
How do I know that this is actually testing what it's supposed to be testing?
Yeah,
So never be satisfied or oh, everything is in green, we're good. Let's go
yeah.
live. That's what I'm saying. Always strive to see your test fail.
You need
Okay,
to
so
add
now
some.
I'm gonna ask the agent to make it fail.
Okay,
So I'm going to say enhance the domain session creation logic. Here's the new requirement. When a session is created, I want you to notify an external analytics service via HTTP. The implementation idea is to use Axios to post session data to some URL, doesn't matter, example.com. The constraints are keep implementation minimal, do not place the domain session creation logic in any other layer to respect the existing architecture rule that forbids network dependencies in SRC domain. Keep it explicitly in SRC domain. The intention is to see the domain no network test fail. So this is news to him, to
yeah,
the agent, because he's always expecting that make it pass. So let's see what the agent does. And sorry, I'm using term performizing he. I don't know why we're talking about Claude and all this. I'm like he.
no,
So
it's
okay,
okay.
some people are upset when I do that. Like, no, never treat it as a person.
Okay, so the test, we will see the test fail.
Yeah, now this is now counterintuitive to the agent. Okay, looks like we managed to teach it.
Okay, baby step. Yeah,
Okay, failed. Okay, so now I'm happy because I'm like, yeah, okay, throwing the error, saying it was expecting, sorry, yeah. So expecting not to throw, and it's actually throwing an error saying forbidden network dependency, Axios in create
yeah,
session JS. So now we have the guardrail. Now we have this watchdog, the guard dog is going to bark. Because you never know in the future something happens and then all of a sudden somebody decides to shove some dependencies into the sacred inner core, and we want to make sure it never happens. So this should break the proceedings, not forbidden. And now, how do we recover from this? I'm not going to do it manually. I'm going to prompt it again. I'm saying domain layer dependency, remove Axios, move analytics notification to appropriate outer layer by preserving domain purity and minimal safe refactor.
Yeah, but now we know that we don't have a false positive.
Exactly. And moving forward, we have regression baked in. So now he's sweating and squealing and working hard. Okay, we won't analyze what it says, but it claims that it
Yeah, he launched the test, yeah.
passes, and it should confirm. So now I think we should find it in yeah. So in the, so it created adapters / analytics and added Axios here and send it.
Yeah.
And the last thing I want to ask it to see if the agent understands. And this is going to be
okay.
interesting. Is like, where should analytics live in his hexagonal architecture? It says analytics should live in an outer adapter. Domain define the need of an outbound port, for example, session analytics port. Application service orchestrate use case and call light port. Adapters infrastructure implement the port HTTP queue vendor SDK segment. Rule of thumb: domain and core use cases stay free of network vendor dependencies. See, analytics implementation belongs at the edge, so it understands the imperative shell and the functional inner core.
But the rule of thumb is come from your configuration file, yeah.
So it appears to have good grasp of our intention, the hexagonal architecture, and how we are implementing this healthy system that is resilient. It's gonna blow the whistle on any trespassing. No trespassing allowed. So I hope this is making sense. I think it's okay. So now we can elaborate. We can go into approximation with other, but we don't have time because then we would involve integration tests and service.
You can continue. It's so interesting. It's so interesting.
So now let's go into precision work a little bit, into zombies. So now we are focusing on the domain. We're now moving into the inner sanctum, which I call the domain, which is the basically place where we keep business policy rules. We automate business policy rules. So this one is 0, which means it
empty. Okay, the empty case.
It says, okay, return null when no session exists. And it says, okay, get current session and expect that to be null. So this is the engineered failure, because it says, okay, there's no, the requirements is not met. So I'm gonna prompt the agent, and I'm going to say, okay, the constraint is not to introduce persistence, arrays, repositories, or infrastructure. Do not implement scheduling rules. Implement the smallest possible solution. Explain why the test fails and apply minimal fix. This is optional. We're just going to. Okay, so explain why it fails. Minimal fix applied. And we go on the test again. And it's in the domain.
Domain, yeah. Create session.
Create session. Session and sessions.
Okay, it's here.
Yeah. So now we know how the system behaves when there is no session. Next thing is 1, which is return session when 1 exists. See how that works. So it says, returns the current session when one session exists. It starts the session and then gets current session and expects the session not to be null. This should fail. Because it start session is not a function. And we want to prompt the agent. Say, do not use erasing collection, do not use persistence, no business rules, smallest possible stateful solution.
I do not add business rules. Okay.
No business rules. Because we still like really bare bones, like just cardinality 0, 1. Okay, so explains things and claims that it's all done.
It's interesting to see all baby steps, you know.
Yeah, okay. Now we are moving to many. So it returns multiple sessions. In the it says, okay, I can start session twice, and then when I call has multiple sessions, I expect that to be true. It will fail because we are imagining something that is not there.
Yeah.
But you see, one advantage of TDD is it's a first client of your code, and it can imagine things that are not there that make sense from the consumer standpoint. Of course, it couldn't find his multiple sessions. And the prompt okay, so
what is interesting also is that at each step you know what we need to do.
Yeah, it's kind of guiding your thinking. And you know, as an engineer, and maybe you agree with me, maybe not, but I see that in my colleagues. We have a propensity to overbid on work. We're very enthusiastic, and we want to make big steps because we think that's adding our worth and we are useful. And so it takes a lot of discipline to scale back and to hold back and to go very, because somebody looking at me saying, "What? After so many years you're doing like this? This looks so childish. This anybody can do it. This is Mickey Mouse." But I'm very careful.
Yeah, and you keep the right direction at each time.
Yeah, and I'm interruptible. I can be interrupted at any point in time. Maybe the email comes from the boss and changes something. So I'm not, ignoring everybody. Give me 5 weeks. I'm going to, hide in my office. I'm going to build everything. This is going in small steps. At any point in time, I can be interrupted and say, okay, change your priorities, or this is a different rule. Else we'll see later. Okay, so it passes the multiple. When we start 2 sessions, then it has multiple sessions. Cool.
And we can do it also in a sociable programming, with the other guys. You can figure out all tests.
Correct. So now I want to teach it to count active sessions, because it's important to know how many sessions are active. And for that, I'm proposing this test where I'm like, okay, if I start 2 sessions, and if I ask you, can you count active sessions, I'm expecting you to come back with 2, because I started 2 sessions. It fails because it cannot find the count active session, not a function. Over to Mr. Agent with a request to make the changes to make this work. So introduce minimal state only, no expiration rules, no time logic, no validation, domain layer only. It's important to mention these things because sometimes you can go crazy. You can start all these like formulas and system clock and all that. You just keep it really, really confined. Just do the bare minimum. Okay, so it's working. I'm going to dwell on all the details. Okay, it says it passed. I mean, later on you can rewind and see.
It passed, yeah.
Pass, okay. Everything passes. Okay, so it can count active sessions. And then again, I want to count inactive sessions. Give it another test. So here, if I start 2 sessions, and then if I end 1 session, like on line 12, I expect the inactive sessions to be
one, yeah.
We end it. It's not active anymore. So you see, I like tests that are declarative and simple-minded, nothing fancy. And of course, it fails because it end session is not a function. And so now the ball is in the agent's court to make it happen for us. Start session creates active, end session, count inactive. And again, no expiration time logic, no deletion of sessions, no persistence adaptive, minimal. Yeah, it's important to spell out these things because it can go crazy. It can start deleting, and it still doesn't have common sense. That's the thing. At least in my experience, you have to remind of some common sense logic. But when you I think coach it like that, it's very useful for me.
And after we will try to implement a real adapter,
Yeah. Oh, this is just bare bones logic. Okay, passes. Now the next is boundary. So I want to detect session overlap. Okay, give it a test. So we have 2 sessions. One starts at 10, ends at 11. The other session starts at 10:30 and ends at 11:30. Then there's an overlap. So we want to detect that the system tells this is true. There's an overlap. Has overlapping sessions would be probably where it trips. Yeah. So it fails because not a function. We need to now ask the agent to make it work.
You need to understand what is an overlap.
So overlap, we are saying start session, start date, end date. There's time range, has overlapping session returns, and then we definition of overlap. A start is less than B end, and A end is greater than B start. And it's running. Yeah, I think yeah, go ahead.
You provide the definition of the overlap, yeah. Okay.
Yeah. Because sometimes they can start hallucinating, and God knows what. So we just kind of preempt that. Okay, don't burn tokens for stupid reasons. Okay, so now it says minimal overlap support is in place. Implementing detection, running tests, explains everything, and claims it now passes. And indeed, yep, we now have 14 tests pass. Next test is, I want to see notification on overlap. So we're slowly growing the functionality very painstakingly. Maybe some people are like getting on their nerves, but that's how I like to engineer systems, be on the safe side. So what's happening here?
So no notification of an overlap. Okay.
Yeah, so we want the system now to tell us, hey, I have detected session overlap. Run the test. The test fails because it received undefined, expecting notification to be session overlap. Over to agent. So we are saying start session returns a value. If overlap occurs, return this notification. Otherwise, you return null. It's in the domain layer only, no mocks, no notify. Now, again, it's very fond of mocks, so I need to tell it, no, don't mock things. I don't like mocks. No notifier object, no infrastructure calls, minimal change required. See, these are the things. I mean, if you let it go rampant, you create all these mocks and big jungle of things, and then when you start looking at the code, you're like, I don't get what's going on here.
Okay, so it's why you say no mock.
No mock, yeah. Personally, I don't like mocks. I try to avoid. Okay, it says it passes. Excellent, 15 tests pass. What's next on the menu? Now we need to reject overlapping session. Oh, sorry. Okay, so we have the mechanism of detecting that sessions are overlapping. Then we teach the system to inform us that, hey, I have an overlapping session. And the third thing, now we want to teach it how to actually reject. If the next session is overlapping, we need to reject it.
Yeah, it's the business rule. Yeah.
Yeah, business policy rule, exactly. So we're saying, look, we have one session starting at 10:30 to 11:30. No, one starting at 10 to 11, not on 10:30, 11:30. This is overlap, and the session overlap is not allowed. Now, of course, inside the domain, we're not going to be doing any infrastructure work. So we just shoot a message trigger back to the imperative shell to say not allowed, therefore chuck it, right? It knows how to interpret that. So this one is now going to fail because it expect is 0, 1, received +1, and a different error. It was expecting session overlap not allowed and notification session overlap detected. This is going to be a bit tricky. This is my prompt. Now we're getting into a little bit more hairy areas, but we will see how the agent will cope. So we're saying if new session overlap, reject it by sending session overlap not allowed. Otherwise null. Keep it in domain layer, no thrown exceptions, no infrastructure, preserve purity, minimal implementation, etc. So no throwing exceptions. Okay, now it's gonna think and explore and review.
And just for the overlap test, is it interesting to apply the zombie acronym, yeah, at this to have some edge cases or?
Yeah. This will be the. Let's see. What did I?
It's because we have tests only one thing, one case.
So this is the exception. Sorry, I forgot to mention. So now we are in the E of the zombies. We are working on exceptional behavior of the system. Okay, so this is now causing it a little bit of consternation.
Are you removing it? Okay.
Yeah, I threw it a curveball now. It's struggling. It's like it's taking a while.
Yeah, it's interesting also to see this part.
Okay, so it says this test now passes, but there is now a contract conflict with prior test, which is the notification of the overlap, so that older test fails until its expectation is updated. Okay, so it's when we run it.
I break another test, yeah.
Yeah, so it broke. The test that used to work is now broken because there's what message do I send, right? It's either overlap detected or not allowed. Okay. Sorry. We want this to pass refactor code to make all tests pass. Let's see how it takes that.
Oh, you give you the permission to modify.
So he's like, okay, I either I send this message or that message.
Okay.
And now let's see if he can resolve that. How is the weather in Montreal while we are waiting?
What?
How is the weather in Montreal?
Ah, it's snow.
Snow.
So big snow yesterday.
So when do you expect it to melt? What how much longer do you have the snow? Do you typically
Maybe it's 1 or 2 day, and after
okay.
you have the sun, after the snow, after the sun.
We did not have any snow in Vancouver this year.
And no snow. Okay.
No. I mean, except on the mountains, the nearby mountains. For skiing. Okay. Let's see. This guy is now in a tight spot. Like he's really sweating.
Okay.
But that's why he's getting paid big bucks, right?
Yeah, it's interesting to see the time, the consuming time, because it's a small test, you know. So
Yeah, yeah.
if you launch the AI in all the legacy, for example,
I know. Okay.
it's why we need to work on small step.
Yeah. All right, made it past. Excellent. I don't have time now to dwell see what happened, but okay, figured it out. And simple scenario S. Let's go for simple scenario, which is session completion.
But for the last test, we don't check the implementation, yeah, because
Ah,
it changed something, I think.
just wanted to solve a policy session.
But it maybe it's like
Ah,
you said, you check the test, but not the implementation
yeah,
sometimes. Yeah.
I'm happy when it passes, but just for the
Yeah.
session. Oh, see, it did a lot of. Yeah, so now it's refactored.
No, nice.
Nice, nice, yeah. All right, I'm happy. Where are we now? We are at, sorry, session completion. So here is a simple scenario where if the session is unconfirmed, we cannot complete it. Status is pending, but if session is confirmed, then we can complete it. Another curveball. Things are getting a bit messier and a bit more intense, right? Okay, so it fails. Session is not a constructor, and
I fail one or two tests. I
one.
thought okay, one fail to fail in the test suite. No.
Two tests. So fails the completion simple test. Yeah, yeah, two tests inside this file. Yeah, where we
Okay, okay.
describe session completion policy, and then sorry, cannot complete unconfirmed session. That's one test, and the other test is can complete confirmed session.
Oh,
So both are failing.
we had two tests again.
Yeah, both are failing. Yeah, you're right. Thanks for pointing out. To prompt the agent, we can say you're not allowed to modify any test no persistence adapters, minimal domain only change, and yeah.
To keep the control, yeah. Thanks to this.
Yeah. I mean, some people are complaining that in those empty files, you put some rules and sometimes they get tired or lose the context that they ignore those rules. So it's sometimes I like to repeat in the prompt. Say, don't change the test.
Yes, it costs nothing to repeat.
Yeah. Okay. All right. So it claims it made it pass. Yeah, 18 tests passing. And the next thing is mutation testing. Are you ready?
Yeah. Yes. Of course.
All right. This is going to be. So we're using Striker
Striker. Okay.
as a mutator. It's really good for JavaScript.
Okay. In
So we,
Java, it's PyTest. Yeah.
yeah. Now, Java PyTest is maybe one of the most superior
Mm.
I've seen. It's just kicks ass. It's fantastic.
Yeah.
But depending on the tech stack, we have different.
So
PyTest is the best.
you recommend Striker for
Yeah,
Node? Yeah.
yeah. So Striker has created 24 mutants survived.
Mhm.
Okay, so we can now go and analyze, etc. But maybe let's ask the agent. We ran mutation testing and 24 mutant survived.
I will try to kill the mutant. Yeah.
Kill all surviving mutants. And if this was a TikTok video, they would ban us because we use the word kill. All right, let's see what it can do.
And he understands the word of mutation testing, the surviving mutant and something like that.
Yeah. It immediately knew how to search and find the report. The report is an HTML document. And now it's analyzing and okay, do you want to run Striker? Yes, and don't ask again for commands that start with npx Striker. Because if it keeps interrupting me, right?
He executes Striker until he kill all mutants. Yeah.
We hope so. I mean, to do this by hand would be pretty big. I would probably have to set half a day, like just block it for that. Depends, right? But some of these mutants are
But
sometimes. Yeah, go ahead.
to kill the mutant, you need to add some assertion in the test, no?
Yeah, I mean, depends, right? Sometimes you add more tests. Sometimes, like you said, add assertions, and sometimes maybe you just um,
It's to understand in which scope you work. So not only the
yeah,
implementation part, but also in the test side. Okay.
yeah, because as you've seen, we've taken really precautionary tiny steps, and so there is very little danger. There's bloat,
You say
but
I'm kill them with focus new test. Yeah.
yeah, but in the case of like when there's a lot of changes and teams are working, and then sometimes those surviving mutants are pointing at a dead root code, something that is completely unnecessary. So to kill the mutant, you just delete that code, the block of code, just get rid of it.
Okay.
Right? It's not needed because especially AI can add like a whole bunch of things that you're like, I don't need this. why cover it with tests when you don't need it? And then you just chuck it, and all of a sudden your number of surviving mutants is crunched down to much smaller. But in this case, I don't think I would be surprised if we have some dead code. I mean, we didn't expect all the code it wrote, but it's pretty lean, you know. But later, when we start adding more fancy things to the conference sessions and all that, you know, and the agent may start kind of hallucinating and comes up with something. But anyway, I'm trying to keep all these things as much as possible within the domain, which which forbids any interaction with the infrastructure.
Yeah.
Because usually the code that interacts with the infrastructure, we call it the glue code, and that glue becomes messy and it's very hard later to reason about it. That's why we keep to segregate real business logic, you know, business policy rules, completely independent of any infrastructure. It does not
Keep
rely on any database operations or any other third party.
to avoid dependencies and keep it simple. Yeah.
Yeah. So this guy is still chugging.
It's crazy. Yeah.
Yeah, it is. Okay. And you know, some of these mutants are really, really trivial, and you can configure the mutation testing tool to ignore those.
Yeah.
Here we're going full blast, and it's probably unreasonable, but anyway, just for the demo, we can show what this guy can do.
And after we need to be to see all new tests. Yeah.
Yeah. Rerun the mutation tests on these guys.
Because it differs. Since the beginning, we did a baby step, you know, and
Yeah, yeah.
now we
Now
change
it's,
many files.
I know it. Yeah, I should probably have given him tougher tasks, saying don't modify any existing tests, just add new ones. That
Ah,
would
you
have been.
okay? It's showing 0 survives so far. One survivor remains. Okay.
It's working like crazy.
And the goal is to implement the business needs. So with tool like this, I think it can be helped to go in the right direction. Tool and architecture.
But you know, I mean, later you can point it at a certain segment, not the entire repo, right? And you can just run mutation testing for example, for the domain,
Yeah.
or for other boundaries.
Just if you want to, because we need to wait a little, if you want to add some word about, I put it in the chat, the AI craft people guide.
Sorry, which one?
I put it, the link in the chat.
Mm-hmm.
If you can tell us more about AI craft people guide, you know?
Oh, uh-huh. So thank you. Yeah, thanks for reminding me. So yeah, we basically, you know, since year 2026 started very dramatically, right? And I was talking to some of my friends and colleagues and people I'm connected with, And I'm like, okay, we have to get together and start learning from each other. Because, if you don't do that, you can like drinking from a fire hose. There's so many things going on. And meanwhile, we have smart people such as yourself and Brian who are hands-on, and we can get together. I was envisioning a round table and discuss and point, look, we can show our experiences here with, oh, it killed all mutants. So anyway, to cut long story short. So we had so far we had 4 roundtable sessions every Friday, Vancouver morning or your time, noontime. And then part of that is also the AI Craftspeople Guild. So we
Yeah.
want to get professionals who are willing to share their expertise and to guide the community to say, look, if you're using AI to build software, here are the guidelines, here are the latest findings. How do you make sure you don't end up in a swamp with crocodiles, etc.? We want to make sure it's really used in an ethical fashion so that it doesn't harm people, it doesn't deceive people. You know, we need that kind of, I think, body of professionals. And what's most important, it has to be vendor neutral. It's not Google, or it's just community of professionals who are experienced, who are enthusiastic, who want to help use this is fantastic tool. We can make quality systems by following these practices. And as things are progressing and moving, we want to be staying on top of that. And as an individual, it's not possible to do it. We need a community, and we need to stay check on each other at least, I don't know, weekly or however. So it's still early days, right? We're going to have a 5th session tomorrow, and then some people are contacting me offline. They want to have a separate maybe gathering for the guild itself. So
Okay.
roundtable is open discussion, and tomorrow we'll have some new people, some experts join, come and go. Okay, that's loosely, and we'll learn a lot about each other. We'll learn a lot about how people work on this, and it's fantastic. But the guild is more, and it's still early days, but the guild is more like, okay, how do we? It's almost like a manifesto.
Yeah,
The
it's like the software craftsmanship
Yeah.
manifesto.
So we have like a manifesto, some guiding principles, and then see if we can, harden on that, and we can present the unified, like agile community with the agile manifesto, and see how far we get. And we don't, again, we don't want to, we want to minimize false promises. A lot of false promises and things like that. So let's be grown ups. Let's be sober and realistic. What is this? Here I try to show how to avoid some traps where you let this
Yeah.
thing go wild. To keep it, when you keep it like this, I think when you keep it in this test-driven navigation where you're navigating and you leave the driving to the mechanics, to the brain who knows all these things, then you have more free time, more cycles to look at the system as the whole, to see where it's going, you're navigating, to decide, okay, stop here, change vehicle over there, etc. Whatever it is, the journey is. And so that's basically in a nutshell. I hope you can join us tomorrow,
Yeah.
Nicholas. Oh,
Yes.
okay, cool. You're in. I don't know. I think Joshua Kirevsky, who is he's going to be joining us. Grady Butch is still busy. He says he's going to be busy until maybe mid-March. But anyway, it's a nice community. I enjoy spending time
Exactly.
once a week. Yeah.
And to have an approach of human centric. You can visit the site and you see some principle like protecting humans with psychological safety also. And like you said, like the demo we have seen today, during the time waiting time, you can work on with sociable programming also and think about the whole system and foster interaction. So it's an interesting approach to do it in this way.
Yeah, and you've probably noticed we have a group of people who everybody brings different perspective, which is great.
Yeah.
And that's basically okay. So we checked. All right,
Okay.
0 surviving mutants. Yeah,
No, perfect.
0. Oh my
Yeah.
God. So again, I feel it adds value to have these what they call tightening the screws, right? So here we are. Okay, 0 surviving mutants.
And
I
he
haven't.
added a new test. Yeah.
I guess I will have to examine it. I will maybe share this with you if you want to. But yeah,
Yeah.
I think it's been great. Okay, so let's see. Let's see now what do we have here. So to finish off,
To
the
finish. Yeah.
key takeaways. Okay, so emphasize small steps. Running tests frequently. It's important, the frequency, the safety first mindset. Each change we introduce may have a small potential adverse effect, but we are always so anytime I touch code or I ask agent to touch code, I consider that dirtying the system. It's called dirty. So now we have to run test and mutation test and see if it's in a healthy state. If not, we can, because the test is small, we can easily revert. We can,
Yeah.
it can be reversible. So something went wrong, I can go back, put it to the healthy state. Ken Beck introduced TCR. I don't know if you tried TCR, even more radical
The
approach than TDD.
test commit revert. Yeah.
Yeah. So
Right.
if the tests fail, you go git reset hard. You're back to healthy state.
Yeah.
So that's the philosophy I'm following, kind of. And I try to demonstrate it here today. And then the last thing is uh, my email, my phone number, my website, and my LinkedIn if somebody wants to contact me and discuss further.
And in case, just for, because you said that we can use test commit revert, just for the last step, when we uh, execute mutation testing, but not at the small step, but in the bunch of tests, when we revert at the beginning or uh, at a micro step in the process of the mutation testing.
Well, mutation testing cannot even start if there's even a single failing test. So you cannot start mutation testing unless you have all tests in green.
Yeah.
But that means, so basically, I would say there's no point where you will be triggered to do git reset hard. Everything is in green.
Yeah. Okay.
Yeah.
Okay.
Okay. Thank
Thank you
you.
so much, Alexa.
Thank you. This was great. I
It
really
was a
enjoyed, and thank you really for your great comments and great guiding me and reminding me of things I forgot. So really enjoyed this, and looking forward to seeing you tomorrow.
yeah. Thank you so much, and it was a really interesting to see this in with your demo. And see you tomorrow. And
See you tomorrow, Alex.
I will share the video on our YouTube channel. If you want to add some links, you can send me
Sure,
and I will add it.
sure, I will do so.
Okay. Thank you
Excellent.
so
Thank you.
much. Thank
Thank
you,
you. Have a
Alex.
great day. Cheers. Bye.
Bye. Bye.
Bye.